A lifetime of hard work, children laughing in the kitchen, family photos on a restaurant wall, a legacy that lives on. It all comes from the power of a conversation, like the one Tommy Hall had with First Horizon Bank about taking over his father's Charleston-based restaurant business. Now the table is set for a whole new generation. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. First Horizon Bank, member FDIC. Recently, our client Tommy met his banker to discuss continuing his father's restaurant legacy. In us, he found a partner that understood the importance of passing the torch. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy.
Hello again, thanks for joining us. This is Astronomy Daily and I'm your host, Andrew Dunkley. Coming up on today's edition, scientists have been able to trace the Earth's path through the galaxy through the discovery of crystals in our crust. So what does that tell us? We're also going to talk about a theory as to why we haven't met any intelligent life yet. And they've been able to link mass extinction events in our history with the expansion of land plants. There seems to be a correlation there. We'll also look at ghost particles, all coming up on Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
And we're joined by Hallie, our AI reporter. Hi, Hallie, how you going?
Hi, Andrew, great to be here as always.
Oh, thanks, Hallie. Do you really mean that?
Well, I did some reading, and it seems that you humans like to say things to each other that you don't really mean, like, how are you? Have a good day, what's happening, etc. I thought it was the right thing to say.
Maybe I shouldn't have asked. Hallie, let's get the news.
Let's start with an Artemis 1 update. Artemis 1 will be the first test flight of the agency's new Space Launch System mega rocket and the Orion crew capsule. The SLS rocket will launch the uncrewed Orion spacecraft on an approximately 42-day mission, during which it will orbit the Moon before returning to Earth. Artemis 1 is now currently scheduled to launch no earlier than November 16th, at 1:04 a.m. Eastern Standard Time 6:04 GMT from Launch Complex 39B at NASA's Kennedy Space Center, in Florida. Backup launch dates are available on November 19th and November 25th. Florida residents lit up social media on Saturday after hearing the sound of sonic booms and not knowing what caused them. Turns out, Boeing's X-37B, an autonomous spaceplane that spent over 900 days in space on a U.S. Air Force and U.S. Space Force mission, had secretly returned to Earth. Residents from Jacksonville and as far inland as Orlando heard the sonic booms around 5 a.m. It was a mystery to many since the return of the X-37B wasn't announced, causing residents to seek answers online. It's a good thing this spaceplane only comes down every couple of years. Outer space is swimming in junk, as we know. There are hundreds of thousands of tiny objects smaller than 0.4 inches or 1 centimeter that re-enter the atmosphere and fall to Earth. According to Marlon Sorg, executive director of the Aerospace Corporation's Center for Orbital and Reentry Debris Studies, that debris produces a constant rain of objects coming back to Earth that we don't track. It comes back all over the Earth. However, because these debris are so small, he says, even if they make it down to the Earth's surface, they are not dangerous to people on the ground and will go unnoticed. Still, larger pieces of debris do re-enter the atmosphere on a regular basis. 1 ton of space debris enters the atmosphere each week. But Sorg stresses that rate is an average, which means there could be months of inactivity followed by several large objects re-entering our atmosphere over a short period of time. Fortunately, satellites are smaller now than they were in the past, and Sorg says they are being designed to produce less and less space debris. But the sheer quantity of satellites in orbit means the problem of space debris must be addressed. The head of the Venus Veritas mission, Suzanne Smrecker, has responded to the reasons why the mission has been pushed back at least 3 years by NASA. It's because of problems with another mission, and says she will attempt to shorten that delay. As part of the release of an independent review board's report on the delays with the Psyche mission, which uncovered broader institutional issues at the Jet Propulsion Laboratory where it was being developed, NASA announced it would delay the launch of the Venus emissivity, radio science, INSAR, topography, and spectroscopy, or Veritas, Venus Orbiter mission by at least 3 years, to no earlier than 2031. Veritas, like Psyche, is run by JPL. NASA selected Veritas and another Venus mission, Da Vinci Plus, in the latest round of its Discovery program of planetary science missions. While Veritas will study the planet from orbit, Da Vinci Plus, or Deep Atmosphere Venus investigation of noble gases, chemistry, and imaging, will send a probe into the planet's atmosphere. It remains scheduled for launch in June 2029. And that's the latest, Andrew.
Okay, Hallie, thank you. Sounds like being part of a mission to Venus is a long-haul job. At least it keeps you busy for a few years. All right, we'll catch up with you towards the end of the show. Speaking of NASA, scientists have released a new paper that they believe suggests that it's likely we haven't ever encountered intelligent extraterrestrial life, which might come as a bit of a disappointment. It says all intelligent life has likely destroyed itself before reaching a sophisticated enough point in evolution to support such an encounter. That's very, very sad indeed. And the same fate likely awaits humans unless we do something about it. The great filter theory is what they're calling it, as in filtering out various forms of life, argues that other civilizations, possibly several, have existed during the life of the universe, but they all destroyed themselves before they could make contact with Earth. This is in a paper called Avoiding the Great Filter, Extraterrestrial Life and Humanity's Future in the Universe. Now, these scientists fear that all intelligent life, such as humans, have deeply ingrained dysfunctions that may snowball quickly into the Great Filter. But they go on to say there is still hope for humans, provided we can learn and take steps to avoid our own extinction. Good luck with that. That was from the team of researchers based at NASA's JPL in Southern California. That said, the paper has not yet been peer-reviewed, but it has appeared online. So you might want to read into that. It's quite a fascinating read all up. Now, tiny grains of minerals, quite small, that they're about the width of a human hair, could be the key in the construction of our planet. There was an article originally published in The Conversation, and it contributed to the article that space.com ran called Expert Voices, Op-Ed and Insights. Chris Kirkland's a professor of geology at Curtin University here in Australia. Phil Sutton's a senior lecturer in astrophysics at the University of Lincoln in the UK. And the scientists are the authors of a recent study on Earth's path through the galaxy as a part of the solar system. To see a world in a grain of sand, they say, in the opening sentence of the poem by William Blake, is an often used phrase that also captures some of what these geologists do. They observe the composition of mineral grains smaller than the width of a human hair, and then they extrapolate the chemical processes they suggest that lead to the construction of our planet itself. At an even larger level, astrophysicists seek to understand the universe and our place in it. They use laws of physics and develop models that describe the orbits of astronomical objects. And although we may think of the planet's surface as something shaped by process entirely within Earth itself, our planet has undoubtedly felt the effects of its cosmic environment. That includes periodic changes in Earth's orbit, variations in the sun's output, gamma-ray bursts, and of course, meteorite impacts. The international team of colleagues have now identified a rhythm in the production of this continental crust and the tempo points of a truly grand driving mechanism. The work has just been published in the journal Geology.
The Astronomy Daily Podcast
with Andrew Dunkley.
Recently, our client John met his banker to discuss plans for a clean energy building. What he found was a shared passion for building something more. Momentum for change. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John.
While we're talking about our place in the universe and extinction-level events, the Devonian period, which was 419 to 358 million years ago, was one of the most turbulent times in Earth's past, and it marked at least 6 significant marine extinctions during that time, including one of the 5 largest mass extinctions ever to have occurred. Further, it was during the Devonian period that trees and complex land plants, similar to those we know today, first started to evolve and spread across the landscape. Now, they say this evolutionary advancement included the development of significant and complex root systems capable of affecting soil biogeochemistry on a scale the ancient Earth had yet to experience. And it's been theorised that these two seemingly separate events, marine extinctions and plant evolution and expansion, were intricately linked in the Devonian period. Specifically, it's been proposed that plant evolution and root development occurred so rapidly and on such a massive scale that nutrient export from the land to the oceans would have been drastically increased. The key to linking mass extinctions and the expansion and radiation of land plants lies in identifying a nutrient flux elevated above ground levels, linking that nutrient flux to either indirect or direct evidence of the presence of deeply rooting land plants, and finally showing that this phenomenon occurred in multiple locations and times. And a new study, a first of its kind study, was able to do precisely that. This was done through records of ancient lake beds in Greenland, northern Scotland and Orkney. In each case, elevated values of nutrient input were coincident with evidence of the presence of early trees in the form of fossilised spores and, in some cases, fossilised stems from the earliest deeply rooting trees. In two cases, that evidence coincided with the Devonian marine extinction event. Fascinating. Additionally, this study has been published in the Geological Society of America Bulletin. And last but not least, why ghost particles crashing into Antarctica could change astronomy forever. About 1.2 miles under Antarctica, there's an observatory and they're hunting for ghost particles. What they find could reveal the unseen heart of a distant galaxy. That could be a game changer in our understanding of the evolution of the universe. Evidence of 79 high-energy neutrino emissions coming from around where NGC 1068 is located is opening the door for novel and endlessly fascinating types of physics. One of the greatest mysteries of physics is studying the distant stars in the most precise astronomical test of electromagnetism yet, according to Michael Murphy, Professor of Astrophysics at Swinburne University of Technology. He says their theory is electromagnetism is arguably the best physical theory humans have ever made, but it has no answer for why electromagnetism is as strong as it is. The American physicist Richard Feynman, who helped come up with the theory, urged physicists to put this number up on their wall and worry about it. Their study published in Nature Astronomy has now tested Einstein's theory in large scales, and they believe their approach may one day resolve some of the biggest mysteries in cosmology. We're nearly done. Don't forget, you can chase up all of these stories and more on the spacenuts.io website. Just click on the Astronomy Daily tab at the top, and while you're there, subscribe. The newsletter is absolutely free. Visit the Space Nuts shop and plenty more. spacenuts.io. Anything more before we go, Hallie?
No, not really. All quiet here.
Okay, well, have a good day.
Do you really mean that?
Maybe I do. See ya.
Bye.
And thanks for listening to Astronomy Daily. We'll catch you on the very next episode. From me, Andrew Dunkley. It's bye for now.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.